Hello everyone, in this video we are going to cover the basics of algebra. The objective is to provide an introduction to algebra, see the various elements of algebra, how expressions are formed and how to make algebraic expressions. Before we get into the details of algebra, let's have a look at some simple examples. What is 2 plus 0? The answer is 2. What is 12 plus 0? Again the answer is 12. What is 2000 plus 0? 2000. So what do we see here? Whenever we add 0 to any number, we get the same number as the answer. In general, if we add 0 to any number, say x, we get the same number x. So this becomes a generalized rule that shows that adding 0 makes no change to any number. Let's take another example. The cost of 1 pen is rupees 5. So what will be the cost of 2 pens? It will be rupees 10. The cost of 3 pens, rupees 15. The cost of 4 pens, rupees 20. And the cost of 5 pens will be rupees 25. So if we generalize the cost of pens, the cost of n pens would be 5 multiplied by n. So what do we infer here? Total cost is equal to 5 multiplied by number of pens. If total cost is represented by capital T and number of pens by n, then T is equal to 5 multiplied by n. This becomes a generalized statement that helps us to calculate the total cost of the pens. For example, if we have 500 pens, the total cost would be 5 multiplied by 500. If we have 2000 pens, 5 multiplied by 2000 will give the total cost. So irrespective of the number of pens, we can calculate the total cost of the pens. Here we see a square of side 2 centimeters. What will be the perimeter of this square? 2 plus 2 plus 2 plus 2, that becomes 8 centimeters. What will be the perimeter if the side of the square is 3 centimeters? 3 plus 3 plus 3 plus 3, that is 12 centimeters. If we have a still bigger square of side 4 centimeters, what will be the perimeter? 4 plus 4 plus 4 plus 4, that is 16 centimeters. So again, what do we see here? The perimeter of the square is 4 multiplied by length of one side of the square. So again we get a generalized formula to calculate the perimeter of a square, that is capital P is equal to 4 multiplied by S, where S is the length of the side of the square and P represents the perimeter of the square. So what do we learn here? What is algebra? Algebra is the branch of mathematics that helps us to make generalized statements and formulae using alphabets to represent the general or the unknown quantity that can take different values. So in the above examples, we have seen that the unknown quantities were any number added to 0, or the size of the square, or the count of the pens, where we have to calculate the cost of the pens. So the unknown quantity is represented by an alphabet and the derived quantity is also represented by an alphabet. So this is what makes algebra. What are the elements of algebra? The first is constants. Constants are the numbers that have fixed value like 3, 4, 6, etc. We know a triangle has 3 sides. So irrespective of the size of the triangle, the number of sides will always be 3. So 3 is a fixed value for a triangle. Next is the variable. As the word means, a variable can have varying values. It is represented using alphabets like X, Y, N, etc. These variables and constants along with mathematical operators form expressions. And when we include an equal to sign, it becomes an equation. In an equation, the derived quantities on the left side of the equal to sign are denoted by capital letters and the variables on the right side are denoted by small letters. For example, in the formula to calculate the perimeter of a rectangle, 2 would be the constant, L and B are the variables that denote the length and breadth of the rectangle. 2 into L plus B becomes an expression, and P is equal to 2 into L plus B is the formula to calculate the perimeter of any rectangle. In this video, our focus is on the expressions that are used in algebra. Now let's see how these expressions are formed. That is, how to convert a given problem in English into an algebraic expression that gives us a generalized rule to solve the problem. First, consider the phrases that involve addition. For example, 7 added to x. This shall be converted to an algebraic expression using the rainbow technique. That is, first write x followed by plus and then the 7. So the expression becomes x plus 7. Let's take another example. X added to 7. Again, using the rainbow technique, the expression becomes 7 plus x. Now you must be wondering, how does it matter whether we write x plus 7 or 7 plus x? Yes, you are right, as addition follows commutative property. But we need to be very careful with subtraction. As we'll see further, this ordering does matter for subtraction and might lead to errors. For example, the phrase is y subtracted from 20. Using the rainbow technique, this would be decoded as 20 minus y. In similar manner, 20 subtracted from y would be decoded as y minus 20. So if we do not follow the rainbow technique, we might land up making wrong expressions. Y subtracted from 20 is different from 20 subtracted from y. There's always make rainbows when trying to make expressions from phrases mentioned in any word problem. Here are few examples for making algebraic expressions using addition and subtraction. The first one is 7 added to x. The corresponding expression would be x plus 7. 12 subtracted from y becomes y minus 12. It is not 12 minus y. Thus make rainbows specially for subtraction. 2 more than y is y plus 2. X less than 9 becomes 9 minus x. The sum of 4 and x subtracted from 10 is 10 minus 4 plus x. It is important to use brackets here. Y added to the sum of 4 plus x is 4 plus x plus y. The sum of x and 4 subtracted from the sum of y and 3 becomes y plus 3 minus x plus 4. Again, the brackets are important. The next two examples are very important. Let's have a look at them. 7 increased by x becomes 7 plus x, and x decreased by 8 becomes x minus 8. Here increased by and decreased by do not follow rainbow. They form expressions the way they are read, that is, from left to right. So after making expressions, do read it again and make sure it has been correctly formed. Multiplication. P multiplied by 6 would be decoded as P cross 6, that is 6P. 4 times Q would be decoded as 4 multiplied by Q, which becomes 4Q. Here the constant is written first and then the variable. Division. Y divided by 10 would get decoded as y upon 10, and 10 divided by y would be decoded as 10 upon y. Here either the constant or the variable could be in the denominator, whatever occurs just after the keywords divided by. Again we have some examples here. 4 times x would be 4x. Y multiplied by 7 becomes 7y. X multiplied by minus 4. Be careful about the negative numbers. X multiplied by minus 4 would be minus 4x. It is not x minus 4. The product of 3 and minus x, minus 3x. 2 times the sum of L and B becomes 2 into L plus B. Again the brackets are important here. 5 times x added to 3 times y is 3y plus 5x. 12 subtracted from 7 times x becomes 7x minus 12. 2 divided by x, 2 upon x. We also use quotient of phrase when we are using division phrases. For example, quotient of x by 7 added to y becomes y plus x upon 7. Half the sum of x and y is x plus y upon 2. Again, after making the expression, do read it again to make sure it has been correctly written. Here are some examples that do the reverse, that is forming phrases from algebraic expressions. 4x plus 12 denotes 12 added to 4 times x. When using the keyword times, the constant is written to the left of times. Let's see other examples. X minus 4y becomes 4 times y subtracted from x. X upon 2y is x divided by 2 times y. 12 plus 4x is written as x multiplied by 4 added to 12. Again the constant is written after the keywords multiplied by. We never say 4 multiplied by p because the variable is being repeated fixed number of times and not the opposite. 20 plus 3a is 3 times a added to 20. 2y minus 10 is 10 subtracted from twice of 5. So what's the phrase for 20 plus x upon 2? It's half of x added to 20. xy plus x plus y becomes sum of x and y added to the product of xy. 2 into L plus B is twice the sum of L and B. So far we have seen how to make algebraic expressions expressions. So what is the use of these expressions? For solving word problems. The first step to solve any word problem is to read the problem, understand and identify the unknown quantity, and let that unknown quantity be some variable x. Then we make expressions and equations using the information that is given in the problem statement. And then these equations are solved to find the value of the unknown quantity. So in this equation, we have focused on how to make expressions and equations using the information or the phrases that are being used in the word problems. There's another use of algebraic expressions to make generalized formulae. For example, we all are aware of the generic formulas we have used so far. For example, the perimeter of a square, P is equal to 4 into S. Area of the square, A is equal to S into S. Perimeter of a rectangle, P is equal to 2 into L plus B. Area of a rectangle, A is equal to L into B. Volume of a cube, V is equal to S into S into S. Volume of a cuboid, V is equal to L into B into H. So here all these small alphabets S, L, B, H are representing the dimensions of the given figure, and P and A and V, these are the derived quantities that we are calculating based on the variables. These are just a few examples. Going forward, you learn many more such formulas that we use in calculations. So there we use algebra. For practice worksheet on making expressions from English phrases and vice versa, visit the website www.maskiacademy.com. For any queries, you can send an email to maski.academy@gmail.com. For more such videos, you can subscribe to the YouTube channel, and if you like the video, don't forget to click the like button.